a blue planet defined by a blue ocean. Today, the ocean covers 71% of the Earth's surface. But spin back in time to the beginning, when Earth was a ball of fire. A red planet devoid of life. About 4.6 billion years ago, our planet was covered by volcanoes. As these volcanoes erupted, they began releasing water as steam. Icy comets from outer space crashed into the Earth's surface, releasing more water. Slowly, trapped water vapor formed a thick atmosphere. Earth began to cool. Water vapor fell as rain to create the first ocean, triggering the emergence of life on our planet. Fast forward to the present. The ocean is still the key to our survival. Not only does it control our climate, but it provides us with food and oxygen. In this view of Earth, green areas represent concentrations of phytoplankton. Phytoplankton are microscopic organisms that capture energy from the sun. Like plants, phytoplankton take in carbon dioxide and release oxygen. They provide at least half the oxygen we breathe, and they put food on our table. Phytoplankton are at the heart of the ocean's food web. They are food for small animals, which are food for bigger fish, which are food for us. Where phytoplankton are abundant, that is where you'll find the world's richest fishing grounds. For most life on Earth, energy comes from the sun. But the link between that massive sun and us is forged in large part by microscopic phytoplankton. We have these tiny ocean organisms to thank for giving us air to breathe and food to eat. Of Earth's surface is covered by the ocean. But if you could drain all that water, you'd be amazed by what you would see. Continental margins, ribbons of life connecting land and the deep ocean, trenches 10 times deeper than the Grand Canyon, and the mid-ocean ridge system, the world's longest mountain chain, longer than the Rockies and the Andes combined. The mid-ocean ridge system is shaped by movement in Earth's crust. The crust is made up of slabs called tectonic plates. These plates slowly jostle for position, moving at about the same speed that your fingernails grow. For billions of years, the tectonic plates have been on the move, changing the arrangement of land and sea. Take a look at the position of the world's continents today. As we move back in time, watch how they change position. Millions of years ago, Australia was closer to the South Pole. Long before it was part of Asia, India was its own island. The Persian Gulf was wider. Africa was split in two parts, as was North America. Florida was completely covered by water. Long ago, South America and Africa were joined, fitting together like two pieces of a puzzle. 240 million years ago, Earth looked very different. All the land was joined together in one supercontinent called Pangaea. And there was one super ocean named Panthalassa. Today, the plates are still on the move, bumping and sliding against one another. Movement at the plate boundaries results in most of the world's volcanic eruptions, including those underwater. Plate movement can also trigger earthquakes. Each dot in this view of Earth represents an earthquake that happened within the past 50 years. When an earthquake occurs underwater, it can generate a tsunami, a giant ocean wave. That's what happened in December 2004. An earthquake at the meeting point of the Australian, Indian, and Burmese plates uplifted a massive section of seafloor. It created tsunami waves that radiated outward, moving through deep water at the speed of a jet plane. By the time the waves reached shore, some were as tall as a 5-story building. 250,000 people lost their lives. The ocean's overwhelming power reverberated across the globe. The water in the ocean is constantly moving. Every drop of water is connected. Imagine dropping yellow rubber duckies at different points all across the ocean.